All right, let's talk about the journey every developer takes. It's that road from writing code that's, well, a confusing mess, to crafting software that's an absolute joy to work on. Today, we're diving into the best practices that'll take your projects from frustrating to truly fantastic.
Oh man, we've all been there, right? You crack open a project you wrote 6 months ago, and it's like staring at ancient hieroglyphics. You have no idea what's going on. That feeling, that's exactly what we're here to fix.
And this slide just says it all. On the left, we've got the headache. You know the type: weird spacing, variable names that make zero sense, and not a single comment in sight. But on the right, that's the cure. It's clean, it's commented, and you know exactly what it does in seconds. Our whole goal today is to give you the tools to live on the right side of this screen.
So where do we start? Our first, and I mean most important stop, is readability. Because think about it, if you can't easily read the code, you can't understand it, you can't maintain it, and you definitely can't trust it. This is the bedrock for everything else. The secret weapon for readable code is something called a style guide. It's not about being picky, it's about being consistent. When all the code follows the same rules, your brain can focus on the logic, not on trying to figure out someone's weird formatting choices. For anyone in the Python world, the undisputed king of style guides is PEP 8.
So what's actually in a style guide? Well, it's mostly common sense stuff. Like, instead of a cryptic variable called UA, just call it user_age. It's a tiny change that saves so much confusion later. Using consistent indentation, usually 4 spaces, gives your code a clean visual structure. And just like you use paragraphs in an essay, you should use blank lines to group related chunks of code. It's all about making it easy on the eyes and the brain.
Now, you could waste hours and hours arguing with your team about where to put a comma or whether to use single quotes or double quotes, or you could just let the computer handle all of that for you.
And this is where the magic happens. You've got tools called linters, like Flake 8, which are kind of like a spell checker for your code style. They'll point out all the problems, but even better, auto-formatters, like my personal favorite, Black. You run one command and poof, your entire file is perfectly formatted. It's an absolute game changer.
All right, on to our next big headache, functions that are a total mystery. You know the kind. It takes something in, it spits something out. But what on earth is that something? A number? A list? Who knows?
Just look at the difference here. The before version on the left leaves you totally guessing what items could possibly be. But the after version, using what we call type hints, is crystal clear. It tells you, hey, I expect a list of floats, and I'm going to give you a single float back. The guesswork is just gone.
And you can get really specific with these. Need a dictionary that only has string keys and integer values? No problem. What about a variable that could be a string or it could be nothing at all? None. Optional str handles that perfectly. It's all about removing any and all ambiguity from your code.
But here's the real superpower. Type hints aren't just for us humans to read. You can use a tool called a static type checker, like MyPy. It reads all those hints and actually checks your code for mistakes before you even run it. It can catch bugs, like trying to add a number to a string before they ever have a chance to crash your program. It's incredible.
Okay, so our individual lines of code are looking great. But what happens when your small script turns into a project with dozens or even hundreds of files? Things can get messy fast. The next challenge is taming that complexity with good project structure.
The solution is to think in terms of building blocks. In Python, a single file of code is called a module, and when you group a bunch of related modules together in a folder, that's called a package. By organizing your code into these logical chunks, your project stays clean and navigable, no matter how big it gets.
And why does this matter so much? Well, with a good structure, you can find things faster. When a new person joins your team, they can get up to speed way more quickly. It even makes testing and deploying your code simpler. A really common and effective pattern is the SRC layout, which just means putting all of your main application code inside a folder named SRC. It's a simple way to keep your code neatly separated from tests, documentation, and other files.
Let's move on to what I think is one of the biggest leaps you can make as a developer: testing. The goal here is simple: to replace that feeling of fear when you have to change code with a feeling of confidence. This is the perfect analogy. Think of unit tests as a high-wire safety net for your code. Each test checks one tiny piece of your program to make sure it works exactly as expected.
When you have a whole suite of these tests, you can refactor, add new features, and make big changes without worrying. If you accidentally break something, a test will fail, and it'll tell you exactly where the problem is.
And there's this really cool workflow for it, especially with a tool like PyTest. You actually write the test first for a feature that doesn't exist yet. Naturally, the test fails. Then you write just enough code to make that test pass. Once it passes, you clean up your code, and you start the cycle all over again. This ensures that every single thing you build is tested right from the start.
So, you've built your safety net, but how do you know if it has any holes? That's where a metric called code coverage comes in. It literally tells you what percentage of your code is being run or exercised by your tests. It's a great way to spot the parts of your application that are flying completely unprotected.
A tool like PyTest Cov can generate a report that looks something like this, making it super obvious. Here, we can see that 85% of our code is covered by tests. That's great. But it also immediately highlights that gray 15% that has no test coverage at all. Now we know exactly where to focus our efforts to make our safety net even stronger.
Okay, we've got tools for formatting, for type checking, for testing, but running them all by hand, one by one, is tedious, and it's easy to forget a step. The final piece of the puzzle is to automate this entire workflow.
A really fantastic battle-tested tool for this is a makefile. The best way to think about it is like a recipe book for your project. You write down simple, memorable names for all the common and sometimes complex tasks you need to run.
And it is so simple to use. Instead of trying to remember that long pytest-cov command, you just create a shortcut for it called test. Then, from your terminal, you just type make test. That's it. You can do this for formatting, linting, everything. It ensures everyone on the team is running the exact same checks every single time.
As we wrap up, I want you to remember this. Writing great code really isn't about some secret genius-level algorithm. It's about consistently applying a set of simple, powerful practices that make your code easy for humans to understand and totally reliable for computers to run. Every one of these things we've talked about, from a simple comment to a full test suite, is basically a gift that you're giving to your future self and to anyone else who ever works on your code. So the only real question left is, what's the one thing you can start doing today? Which gift will you choose?